Welcome to the ET380 AM Modulator Lab. We're going to build it in Multisim. Let's start with our AM modulation generators built into Multisim. Okay, here we are at Multisim. Let's go ahead and build our circuit. We have our Tektronix oscilloscopes. We're going to need 2 of those. I'm going to go ahead and build both circuits here. So we're going to go to sources, power sources. I need grounds. And we could attach those. Okay, so let's go to signal sources, and we're going to go to AM voltage source. And let's go ahead and reuse our ground. Okay, and let's go ahead and get our adjuvant function generator. And that one doesn't require ground, so let's go ahead and just connect it. And that's our start. Here's our transistor AM modulator, and let's build it in Multisim. Okay, let's build our transistor AM modulator in Multisim. So let's go up here to transistors. And I'm going to select an NPN, and I'm going to select a BC547. And let's go ahead and go back here and let's get some basics. Let's go to resistors, and we need a stack of those. So we need a 1K. And we need a 56K. And we need a 10K. And looks like a 15. And a 4.7. And we could always just copy and paste and change these in their values. And that looks like off. So let's go ahead and get some standard capacitors. Looks like they are just standard. So let's just get a capacitor, and we're going to need 100 nanofarads. 100 nano. And we're going to need 2 of those. And a 470 micro, 470 pico. Oops, other direction, 470 pico. Okay, and we need a 1.59 nano. 1.59, so we're going to have to modify this guy. Go ahead and just put in the 9. Okay. And we're going to need, looks like 1 inductor. So let's go to basics again, and inductor. And we need a 15.9 micro. Again, we're going to have to modify this guy. So we're going to add a 0.9. Okay. So now we need some power sources, signal sources. So we have AC voltage, and we'll come back and change those later. And power sources, so we're going to need a VCC, and he's going to be a big voltage, so we're going to make him 30. Good. That should be good for our parts. Okay, let's assemble our circuit. So first thing I'm going to do is do a batch rotate. Right click, rotate 90 so we put them in the right orientation. And let's go to view and let's zoom area. See if we can get close. Yeah, that's better. Okay, so we're going to have a 1K on our output. Our transistor's in the right direction, so we're going to put a 10K up here. And our 56K in there. And we have a 15K below it. Oops. Good, and we're going to have, this is our output, so this guy's going to, whoops. Let's move that to make sure he's actually attached, and he is. So here's our output filter and parallel, and where's our inductor? Let's go ahead and flip both of those 90 and see where they end up. Good. Whoops. Rotate 90, sorry. And where's our 100 nanofarad? Let's go ahead and flip him. And we got our 4.7K. And let's go ahead and use this guy. Move him out of the way. And we got our 15K there. And our other power supply here. And our input is 100 nanofarads. And our 470 is an output. We're going to need to rotate him. Alright, so we need some grounds. Let's grab a... And... yeah, we'll just copy and paste him all over the place. And let's go ahead and recenter this dude. Okay. Let's copy, so we're going to need one here. There. Yeah, that'll work for now. Alrighty, so we have this guy connected here. We have our input here. Let's move them over so we get our function generator in there. Ground our function generator. And our 15K, let's move him out of the way here. Yeah, here's our output capacitor. Oops. Okay, here's our 1K load resistor, it looks like. Okay, let's see here. Let's go ahead and put our load. Our 100 nanofarad goes in here. Little bypass transistor, looks like. And put our output filter in here. Okay, I think that's it. Except let's go ahead and fix our. So we have 10 millivolts, so we need to put 10 M, small m, and we're at 1 megahertz, so we're going to need to put big M. Okay, and this guy is going to be 1 kilohertz, 5 volts. Yeah, we're kilovolts, 5. Okay, let me check this here offline. Here's our AM op-amp modulator, and let's build it in Multisim. Okay, let's build our op-amp AM modulator in Multisim. So we're going to need some analog, and yeah, let's go ahead and just grab a 741. Okay, so for some reason they always put these things backwards, so we want the inverting on the top. Okay, so let's grab some. We're going to need some power sources, so let's get a VCC for plus and a VEE for minus. And let's grab some resistors. And we're going to need a 4.9. Doesn't exist, so we're going to make it we're going to fix him. And we need 100K. And we need a 12K. And we need a 9.2K. Another oddball. And we need a 1.2K. Well, that one exists. Okay, and we need a 33. And what else do we need? We need 18.4. Also sounds like an oddball. We'll fix him later. Alrighty, so we need some capacitors. Let's just get some regular OD. So we're going to 2.2 nanos. Okay. And we need 2. And what else do we need? Oops, we need a diode. I'm just going to go ahead and get a we'll pick him up later here. Let's see here. We're going to need function generator, so let's go to sources, signal, AC, and we're going to need a pulse generator, so let's go to pulse voltage. And, oh, we need a transistor, so let's go to transistors, NPN, and we're just going to get a standard 2222. And actually that looks pretty good. So let's go back to our diodes. Let's just get a switching diode because I don't know exactly what they want. Good. Okay, so let's build this circuit here. So here's our VEE. Goes into our pin 4, and we're going to make him 15. And I'm going to copy him. And we'll fix him later. And let's go ahead and we're going to flip him vertically. And we're also going to make him 15. And let's go ahead and copy him. Reassemble our power supply here. Okay. And we got our 2.2 nano above our, and we have 100K. We have a 33. Where'd he go? 33 above. And we're going to have 100K tied into our minus power supply. And we've got a 4.9. Flip him 90. Change him to a 9. And he's going to go into our function generator. So let's move this guy. And let's, I'm missing some ground, so let's go grab some grounds. Okay. And he's going in here. This goes up here. And our 1.2K, where'd he go? Oh, way over here. Some way or another he got attached. Let's rotate him 90. And he's going to go into our transistor. And our 12K goes into there. Where's our nanofarads here? He goes into this guy. And let's rotate him 90. And let's flip him vertically since he's still in the wrong direction. And where's our 12K? Take our pulse generator, borrow ground again. Good. Okay, we got a 9.2. Change him to a 2. And he's going to go into our see if we can move this whole thing down. There we go. And let's move him over, make sure he's connected, which he is not. Perfect. Clean this up. And where's our 2.2? Okay, there's a 1.2. He's going to go into our okay. Okay, so our 18's going back this way. And somewhere we're supposed to have a 95. Looks like I'm going to have to go get him. Okay, 2.2, 2.2, 9.2. Let's go grab, let's go just grab a resistor here. 95. Yeah, we got a 95.3. Let's rotate him 90. Borrow ground. Change him straight to 95. Oops. Okay, I'm going to call this good for right now. Actually, no, we're going to go ahead and we need to change this guy. He's 0.5 volts. And he is at 1 kilohertz, 0 degrees, perfect. This guy is going to be a little harder, so we need to, he's going to be 7.86 pulse time. Pulse width, here we go, and he is 7.8 micro. We're going to use a U. Oops. And our period is going to be 19.61 microseconds. Oddball, but that's it. Okay. Okay, I have a couple minor repairs here, so I need number 2 to come up here to the 100K. And we need to hook our ground into our non-inverting input. And that looks good.